Hello and welcome everyone to the inaugural episode of Positive Discoveries, where I, Ryan Creek, will periodically review some of the latest uplifting and inspiring developments in science. It's November 2023, let's jump right to it. In this episode, I'm first going to describe some progress on the de-extinction of the Thylacine of Tasmanian tiger, and then I'll discuss a really interesting discovery by the James Webb Space Telescope, and then wrap it up with a gene editing therapy for use in human beings. The Thylacine, also known as the Tasmanian tiger, is a really special animal. This is an extinct carnivorous marsupial that's really close to a lot of people's hearts, for good reason. This footage is taken of one of the last living thylacines in the 1930s at the Hobart Zoo. It was an apex predator, and it looked very similar to a dog or to a canid. But that's just an example of convergent evolution. As you can see here, it actually had a pouch. And we still have museum specimens, of course. On the left, we have a skin. On the right, there's a preserved joey. And scientists have had a question for a long time. Could we actually obtain genetic material from these specimens and potentially resurrect this animal? But there were a number of challenges, and then this guy, Dr. Andrew Pask, in his laboratory, they stepped up and they were the first to decode the genome of the thylacine. So this is a real step forward, and it has taught us a lot about this animal. And one of the interesting things that we've discovered is that when we compare the thylacine's genome to that of other living carnivorous marsupials, we find that the closest living relative of the thylacine is not the quoll or the Tasmanian devil like some people thought. It's actually the numbat. They shared a common ancestor somewhere around 40 million years ago. There's some similarities in coloration there, but the numbat is actually a small insect-eating marsupial. So really interesting. And now we have Colossal Biosciences. This company is the real deal, and they have stated that their mission is to de-extinct animals. And they also believe that that research, that progress on that front, could help other animals that are on the brink of extinction. When they first came around, a lot of people thought they were a gimmick. But they're serious. They've raised millions of dollars, $150 million here through a Series B. And they're working on de-extincting dodos and mammoths and thylacines, of course, which they have made a top priority of theirs. Now, we actually have some compelling plans to bring the thylacine back. Step one is complete. They've decoded that DNA. So the next steps would be to edit the DNA of a thylacine relative, such as the numbat, and you get that to mirror a thylacine, and then you fuse it with a Dunnart egg and you can create an embryo. And that embryo could be fostered by a surrogate until it's born, and then you take that out and nurture it, and you can raise this animal to adulthood. Now, the University of Melbourne's Thylacine lab, where Dr. Pask works, they've actually partnered with Colossal Biosciences. So this is huge. This is a marriage of technology, expertise, and cash. And Dr. Pask states that with this partnership, he believes that in 10 years' time, we could have our first living baby thylacine. So yes, we might one day see thylacines hunting again. And now we'll pivot from biology to an incredible discovery in astronomy via the James Webb Space Telescope, also known as the JWST or simply Webb. This is a real triumph of human ingenuity and a major milestone for humanity. As you can see, it is much more advanced than Hubble, its predecessor. Its primary mirror is also several times larger, so it has much greater light gathering capacity. With Webb, we're actually able to see back to the time in the cosmos when the first stars were formed. Quite remarkable. Here you get a sense of just how large it is in comparison to human beings. So what a feat that was, what a miracle of engineering. Actually fold that up and launch it into space via the Ariane 5 rocket, as you see here, which happened in late 2021. When we compare the images side by side of those taken by Webb with those taken by Hubble, we gain a great appreciation for just how remarkable this telescope is. The detail is mind-blowing. Scientists are also very excited about what the telescope can show us outside of the visual spectrum, for example, using infrared. In using spectroscopy on Webb, you can actually analyze the atmosphere of other planets. For example, Mars, where we see carbon dioxide and water and carbon monoxide. Now this is where it gets really exciting. They turned it on K2-18b, which is a planet 120 light years from Earth that orbits this red dwarf star. And when they did this, they found some very interesting things. There's methane and carbon dioxide, and also dimethyl sulfide. Why is that important? Dimethyl sulfide, or DMS, is one sulfur with two methyl groups. It's quite prevalent in Earth's atmosphere, and it is considered a marker of biological metabolism. That's because the only known sources of it on Earth are living things, such as beets, truffles, cabbage, asparagus, and phytoplankton, which produce massive quantities of this molecule in the ocean, and that's partly what gives the ocean its unique smell. So this is a major claim and a significant discovery. Professor Niku Madhusudan, an astrophysicist at Cambridge, whose team discovered this with Webb, stated that on Earth, DMS is only produced by life. The bulk of it in Earth's atmosphere is emitted from phytoplankton and marine environments. If confirmed, it would be a huge deal, and I feel a responsibility to get this right if we're making such a big claim. So the next steps are to confirm this by turning more of Webb's instrumentation on K2-18b, which is shown here in this depiction, which many scientists now believe may be harboring life, and that it is in fact a large ocean world. And last but not least, I want to share an amazing advancement in the field of medicine using CRISPR gene editing tech as therapy for sickle-cell disease. Clinicians such as myself have been very excited about the promise of this technology for years to treat all kinds of genetic diseases, and now we're there. Sickle cell disease is an inherited recessive blood disorder, meaning that it occurs in people who received 2 copies of this mutated hemoglobin gene from their parents. Their parents might have only been carriers. It is most common in people with recent African ancestry and to a lesser extent the Middle East and India. The distribution of that trait also closely matches the distribution of malaria, and that's because we think being a carrier may actually give you some protection against malaria. This condition causes the red blood cells to change into the sickle shape, and that causes them to clog up in the vessels during times of stress. That prevents the delivery of oxygen and nutrients to tissue. That leads to painful attacks, organ damage, and anemia, leading to chronic fatigue and weakness. But now we have CRISPR, which allows scientists to create a genetic sequence with RNA that uses a protein that acts like scissors to then cut the DNA open in a very specific spot, and then they can swap that DNA out for the new created sequence. 2 companies, Vertex Pharmaceuticals and CRISPR Therapeutics, decided to apply this technology to sickle cell disease. And Victoria Gray, a 38-year-old mother, was the first clinical trial patient to be treated with this, and she is feeling great. She said it took about 8 months before she noticed a change, but one day she woke up and didn't feel any pain. And she also states, "I finally get to live a normal life and be happy. It's unbelievable." And even more great news, this therapy was approved for use in the UK on November 16th. We expect it to be approved in the US very soon. I can't wait to see where else CRISPR is going to help us in the future. Well, that wraps up this month's episode. Thank you so much for joining me. My name is Ryan Creek. This is Positive Discoveries. And let's remember to be kind, let's stay positive, and let's stay curious. Until next time, thank you. Goodbye, everyone.